previous video, we talked about how to draw the Lewis structure of methane. Now we're going to work on something a little bit more complicated. And this is an atom that, when you draw all the initial bonds to each of the periphery atoms, you don't end up using up all the electrons in the central atom. So let's start with the chemical formaldehyde. CH2O. Now, last video I told you we need to identify the central atom. Most likely it's going to be the first atom in the molecule. It's the same thing's true here. Carbon is going to be our central atom. So we're going to draw our carbon centrally. We're going to populate it with its valence electrons, in this case 4 valence electrons, 2s2, 2p2. We've got hydrogen, 2 of them actually. And next we're going to draw oxygen. Oxygen has 6 valence electrons, 2s2, 2p4. So we have 1, 2, 3, 4, 5, 6. Now, as with the last video, we're going to start by connecting the central atom to each of the other periphery atoms by a single bond to begin with. So we got one bond here, one bond here, one bond here. But now we have an unpaired electron on the central atom, here on this carbon. So what we want to do next is look for any unpaired electrons on periphery atoms. So if we look at hydrogen, we have our one unpaired electron up here, which means that we can create another bond between carbon and its oxygen. So we're going to erase our electron, and now draw what's considered our double bond. Now remember, Lewis theory, each bond represents the sharing of 2 electrons. So we've got 2 electrons here, 2 electrons here, and now for each bond between oxygen and carbon, we've got 2 electrons here, 2 electrons here, which means that carbon and oxygen are sharing a total of 4 electrons in what's called a double bond.